Oh, all right. All right. So 5.111 or 5.11. Yes. I don't, but you could borrow a calculator. You don't need one right now. You're okay. All right. Undoing equations. Okay. So that's what this section is all about. We're also going to use another term called inverse functions, which we'll talk about in a few minutes. So let me read the little blurb here. Have you ever heard the expression, she knows it forward and backward? Describes someone who understands an idea deeply. Often being able to reverse a process is a way to show that you thoroughly understand it. Today, you'll reverse mathematical processes, including functions. As you work today, keep these questions in mind. So we're going to be working backwards. You'll see what that means in just a moment. So how can I do it? How can I justify each step? I guess I don't know what this is like wrapping a present. Okay. So how do you undo a present? Well, that's pretty easy. Just unwrap it, right? The guys probably did that during Christmas. Wrapping presents person, I think, is really hard to do. But anyway, um, so let's play a little kind of guessing game. So guess my number. Um, Let me give you guys some hints. Um, the number is going to be odd. The number is going to be not prime. You guys know what prime numbers are? Okay, okay, that's good. I'm glad you brought that up. Yeah, a prime number has sorry, a prime number has exactly two factors, one in itself. Like five is prime. Because what are the factors of five? Just one and five, or 23, like one and 23. But like 36 has a whole bunch of factors, right? Like 1, 2, 9, 4, 18. So so the number has not prime. Well, I wrote some notes down here too. Give me a sec. Where did I write my notes down? Oh, also, oh, are you gonna tell Squid Game too? That's brutal that show. Yeah, I finally finished season two. Um, ooh, I should have done a number from Squid Game. I should have done that. No, that's okay. No, I won't do that. Okay, I got the next part. The digits are consecutive. Okay, and the last one, this is
Down before. Can it be going forward and back?
yeah, exactly. Either way,
He wrote this down before, so yeah, it could be this.
Michael Jordan wore this number.
Money Frank.
It's not 23, guys.
25.
What was that? Oh, good. It's 45. It's actually in a Jay-Z song. He talks about
Like that was when he was on the Wizards, right?
no, it's actually when he came back in 96 in the middle of the season. Because there's a rule he couldn't wear 23. So anyway. But 45's
Go, go.
guys, quiet. Actually it was 95. Sorry. Um, Definitely it's odd. 45 is not prime. The digits are consecutive. And even if you don't know what um number Jordan wore, basketball only has two digits, right? Basketball numbers have, we see the basketball teams here, right? So it would be 0-1. Isn't it 0-3? Oh, okay. Anyway. So, well, I said digits are consecutive, so you had to at least have two digits. So anyway, that was just a little game we're gonna play. Guys, quiet. Boys, guys, quiet. Thank you. Okay, let's talk about some terms here. Inverse relation. That's gonna be an equation where the operations are in reverse order. Actually, you know what? Let me just type it. That's gonna be easier. Sorry about that. Let's just type it up. It's gonna be an equation in which the operations are in reverse order from another equation. That's what an inverse relation is. Now, inverse function, it's a slight difference. Let me do different colors here. Similar to inverse relation, but passes the vertical line test. Do you guys know the vertical line test? Okay, good. Actually, I think we did talk about it back in August. Vertical line test. Let me type that up. Is a test we use to see if an equation is a function. That means that each vertical line crosses the graph of the equation just once. And we copy and paste that. And then let's do a different color, so green.
You definitely see that.
No, I know.
Okay, bro.
I know you're being sarcastic. Love the sarcasm. Here. I got you. There we go. Is that better? Okay, good. To see if the inverse which part? Sorry. Oh, there we go. Sorry about that. And I'll show you this in practice in just a moment. So it's a test we use to see if the inverse of an equation is a function. That means that each horizontal line crosses the graph of the original equation just once. Line of symmetry. That should be pretty obvious, I think. A line that cuts a graph in half. Kind of rhymes. And this here is the notation for an inverse function. Or inverse relation. Let me take that back. Because it could be a relation. That's a notation we use. So -1 symbol. So it's not. Please don't do this. You've been warned. So don't do it. It's not the same as this. So some people think when they see this, they do 1 over. That is not true. It's not 1 over. It's just a notation thing to tell you that you have an inverse. That's all it means. When you see f -1x, that means give me the inverse. Does not mean the flip. Like x and -1, you guys should know what that is by now. That was in our final. 1 over x. But it's not the same thing, just so you know. I'll give you guys a moment to jot that down. And I'm recording this too, so you have a recording of it. Actually, let me save this a screenshot. This might be a good idea. There we go. So again, inverse relation is when you have an equation in which operations like addition, subtraction, division, multiplication, or even roots or exponents are written in reverse order from another equation. Inverse function is a relation, but it actually will pass a vertical line test. Vertical line test is something we use to see if we have a function. The vertical lines have to touch us once. Horizontal line test, you still apply it to the original function, but if you draw horizontal lines, if that passes, it means its inverse will also be a function. And then line symmetry, line cuts a graph in half, and then that's a notation for inverse functions, f -1x. Okay, so a lot of terminology. It's kind of important because we're getting a little more abstract as we should in this class. Okay, I'll go ahead and freeze that. I'll just position myself to the next. So let's go to page 2. Okay, and let's talk about inverses. All right. So let me go ahead and clear that. Okay, so we talked about these function machines in the past. A picture of Ania's function is shown below. When she puts 3 into the machine, 7 came out. When she put 4, 9 came out. When she put -3, 5, -5 came out. So pretty obvious. If you make a table, inputs is x, outputs is y. So how would I fill out that table? How would I take the words and put it into a table format? If I put 3 in, what comes out? If I put 4, what comes out? Let's put -3, -5. Okay, we're going to call this the original relation. Okay, we're going to call it the original relation. Now, her function machine suddenly starts working backwards, is now pulling the outputs back up into the machine, reversing the machine's process to return the original input. So, for example, 7 is pulled back into the machine, what value will come out on top? Well, obviously 3. So if you put the 7 back in, what's coming back out? Just a 3. That's all. So now she wants to set up a backward function machine. What would you expect if a 9 is entered? Well, if you put a 9 backwards, we're supposed to get now 4. Or -5 should get -3. It's just a reverse. And the table would look like this. If we made a table with an inverse relation. Hope you guys can read that. Yep, that looks pretty good. You just swap. Really, guys, that's all we're doing. We're swapping X and Y. It's kind of that simple. You're swapping X and Y. Why do we care about this? We care about when we start talking about logarithms. You might have heard about logarithms if you had any siblings take this class. It's probably one of the more abstract topics in Algebra 2. And in order to understand logarithms, we have to understand inverses because they're the inverse of exponential functions. So we have to understand inverses to understand logarithms. So you could see, if you look at this packet near the end, you'll see logarithms. So yeah, just reverse. That's what we're doing. So for D, I already did that for you guys for part D in red. So part D has already been done for you. So what I just did in red, it's done. So you could just kind of point towards it. Let me erase the other stuff here. So this is gone. Yep, that's all. So that should be pretty straightforward for that one. Now explain in words what Ania's backward function machine is doing. And then write equations. Okay. So in words, it's just basically doing this. It's doing the opposite operations of the forward function machine and in reverse order. So it's that's what it's doing. It's in the opposite. Like for example, if it's adding, it would be subtracting. If it's multiplying, it would be dividing. And it's also reversing order as well. So let me draw the tables one more time because I erased it. So this will be original. This will be inverse. And let's try to make some equations here. My short-term memory sucks. So what was the what was the original? It was 3, 7, 4, 9. Good, thank you. So 3, 7, 4, 9. You said -3, -5? Okay. Okay, does anyone have an idea of what the blue, actually let me reposition that again. Yeah, anyone have an idea of what the blue is probably doing? Yeah, I agree. Good. I agree. Nice work. So the original is multiply. And remember PEMDAS. PEMDAS matters a lot too. Multiply by 2, then add 1. Okay. So when you do the inverse, you're actually kind of reversing the PEMDAS as well. Now remember, it was 7, 3, 9, 4. Okay, what's opposite addition, guys? So we're going to subtract 1. Then, and what's the opposite of multiplication? Divide by 2. So is y equal? It's going to be careful, x minus 1, then divide that by 2. Now, is that consistent with the table? If I plug in 7, do I get 3? Yeah. If I plug in 9, do I get 4? Yep. If I plug in -5, do I get -3? Yep. So it's the reverse of the original function. So we subtract 1, then divide by 2. Okay. Now, there's another way you can work these out. I'll talk about in just a moment. But for now, we'll just think of it like this. And CPM is very intentional about it. Whatever you're doing to the original, reverse it for the inverse. When reverse means you do the opposite operation and do it in reverse order as well. So instead of adding 1 as the second step, we'll subtract 1 as the first step. So multiply by 2 as the first step, we'll divide by 2 for the second step. So you're reversing the order and also changing the operation too. Does that make sense? Okay. And hopefully this sticks when you kind of think of it that way, because I'll show you a more algebraic way of doing it in just a moment. So let's try another one here. Actually, well, I'll do this with you guys. Okay, if the crank is turned backwards, what number should be pulled up in the machine in order to have a 4 come out of top? Okay, so here's the thing. So you want a 4 to come out on top. So it means so if we want 4 to be the output, let me write this out. If 4 is the output, let me write that better. Sorry, my use don't look very good. Of the backward function, then 4 is blank of the forward function. So what will go in the blank, guys? Is the input. Or yeah, X, same thing. Sure. Yep. Same thing. Is the input. So that's what you do. So you get 22. Yep.
But if it's backward, wouldn't that be like the inverse?
No, but that's what I'm saying. If you want the 4 to come out on top, what number should be pulled up into the machine? So what should be pulled up would have been the output of the original function. So if you want 4 to be pulled out of the top, that means you want 4 to be the input of the original. So she wants to build a new machine that will undo h of x. Okay, so what is h of x doing right now? H of x is multiplying by 5, then add 2. Okay. So what's the opposite of that, guys? Subtract 2 and then divide 5. Yeah. So the inverse will be subtract 2, then
If you switch the order of them too.
yes, 100%. Yes. And that would make sense, right? Because so your inverse is going to be x minus 2. Because if I plug in 17, I do get 5. Sorry, 3. I do get 3. Okay. So for part C, an undo function is called the inverse. And notation is that. So we write like this. I know it looks kind of funny, but that's a notation for inverse. It's mathematical indicates inverse function. We write like this.
Benefit of writing it, you wrote it under A as opposed to just rewriting it and then plugging it as a form.
So you could do this. You could say y equals our new equation. You could write, and that's fine. There's nothing wrong with it. I just need you to be familiar with the notation. So because when you and this is all part of, I mean, I know this is so far down the road, but like when you start taking calculus in a couple of years, you need to be familiar with that notation. So it's really more just understanding the language of this stuff. That's really what it is. It's like the mathematical fluency. That makes sense. Like for example, if I look at part D, so that means plug in 15. Into the backward function. And what was my backward function? It was x minus 2 divided by 5. So 15 minus 2 over 5 is 13/5. That's all. Is it do it two ways? Let's not worry about that. Just find it. Okay. In your table groups, go and do the next example. I think you guys can handle it. And then we'll check in about like 3 or 4 minutes. So do the next example in your table groups and call me over if you're stuck. I'll freeze the screen and check your guys' work. So you have to make the original equation using the bullet points. Raise to the third power. For cubing, yes, you raise to the third power. It says so right in the parentheses. Find the third power. Exactly. Right. Right. Yeah, how do you pronounce that? I don't know. Nathan, did you finish Squid Game?
No.
What episode are you on? You watched 7 hours in one day? Okay. I had to do like one a night. I did the last two in one night. But there's a third season, so it's give me 1 sec. Hold on. Four. Yes, go ahead, Alexandra. Go ahead.
So here, when I'm writing it.
Yeah.
You do this equation, but then you have to cube the whole thing.
Yes, and then multiply 6 afterwards. Raise to the third power.
Then
6. Yes, correct. Correct. Questions? No? No?
Nice. Yeah, and we multiply, that would be.
Eight on you semester. Yeah.
Cube root. You put a radical. Radical with a 3 on the outside. Okay, you guys should have that so far. Okay. So what I did was I divide by 6. Then I did a cube root. Yeah, I already did part B. Yeah, so did you get the part A correct? Okay, so now I'm doing the opposite. So I have to divide by 6. Yeah, you should do the opposite. So now I'm going like this, right, Jaslyn? So I gotta do x divided by 6, then cube roots. Oh, wait. I made a mistake, guys. Sorry, guys. I made a mistake. No, I made a mistake. I made an error. Yep, I made a mistake. Okay, guys, quiet, please. Thank you. Focus. So Jasmine, you have this now? Yeah, my apologies. My apologies, guys. I got things mixed up. My fault. Okay. Now, Part C is what guys, quiet. Okay, A and B. Questions on A and B. Question, Aiden, you have a question? Yeah, go ahead. Oh, I did 8 divided by 2 is 4. 4 cubed is 64. And 64 times 6, which I did in my head. I could be wrong.
384.
It's 384.
Touted it.
See, that's what you don't do in your head.
That's how you need.
I need a calculator. All right. My bad. 384. Okay. So my apologies. Yeah, I was thinking 6 times 4. I thought it was 16. It's 24. All right. Now this is the part I want you guys to really focus. Guys, quiet, please. Thank you. So when you're asked to verify that the equation part B correctly undoes this, here's what you're doing. This part's a little funky, so just bear with me here. You have to plug the inverse. Let me change colors here for contrast. You must plug
Next unit, we got it.
relation into okay. So, and what you're hoping to get out, I know it's not obvious what is going to happen, but you're hoping to get out is a plain old X. So if you plug the original, yeah, yeah. Let me show you how this works. So, all right, here we go, guys. So let me circle some dark green. Okay. So let's think about it. Guys, quiet, please. All right. So if I put this expression, guys, left, Lincoln, leave him alone. All right. So you put this red, or this thing starts in green into here, right? If I put this into here, what happens to the 6 is I have 6 times all divided by 6. What's going to happen to those 6s? Good. The cube root and cube, what's going to cancel? Good. The 2 and divide by 2, cancel. And lastly, +5 minus 5, cancel. Right. So if I were to show you that process, which is a little bit messy, here's how it all goes down.
Which is that? Oh, that's just how you verify.
Correct. Yes. So I do 2 times cube root. Sorry. 6 minus 5. So you see how these just go away. Then you see how these just go away. You see how these go away. And those just go away. You just get X, exactly. That's how you would verify it.
Two combined.
Correct.
So what was that called?
It's actually called a composite function.
Composite function.
So what are you looking?
Just X. Yeah, we're going to see more of these later on. So that's how you verify it. You can also plug in numbers. You can plug in like 1 and get an output and reverse it. You can do that too. That could work. Well, actually, for example, let's do this really. What do we, guys? What do we get when we plug in 3? We got what, 384, right? So what if I plug in 384? So another way you can verify it too, which is not the formal way or sophisticated way of doing it, but you can verify. It's still valid for verifying. What if I plug in 384? I should get 3, right? If I do 384 divided by 6, use a calculator, it should be 64. What's cube root of 64 is 4. And what's 2 times 4 minus 5? You get 3. So that's yet another way you can verify it. All right. We're at the home stretch. Perfect. Good. Good. You guys have some time to do some homework. Okay. For 516.
How do you get to that?
Because we just did. All right. So all the examples so far have inverses are functions, but not all equations inverses are functions. So vertical line test. and horizontal line tests. Okay. Let me explain the difference between these two, just so you guys are clear on it. Okay. Let me write this in text. Okay, guys, quiet, please. This is to verify if the original equation / graph is a function. All right.
Please.
Guys, watch the language, please. Thank you. Okay. And you apply both. You apply both tests to the original equation / graph. So let's use red here. If I draw a bunch of vertical lines, how many times does it touch? For the first one, how many times does it touch? No, each vertical line. Sorry, each vertical line. Just once. No, each vertical line. Like how many times is that? Once. Once. Sorry, I wasn't clear about the question. So this is yes. So yes, a function. And the inverse. It passes vertical line test. Yeah, so yes, it's a function, guys. 100%. Let me rewrite that. Now let me draw a bunch of horizontal lines. How many times do the horizontal lines touch?
0.
Once still. The horizontal lines. No, it's just flat, right?
Yes.
It's just crossing just once. No. How many times does each horizontal line touch a graph of the first one? Each horizontal line touches just once. So the inverse is a function too. Now here, the original is yes, but the inverse is no. Why is the inverse no, guys? Yeah, they touch twice, so that's not cool. Here, the original is still yes. The inverse is also no, because how many times that touch? Well, actually 3 times. So, but more than once. So if you were to actually find the inverse, which is kind of hard to do, but you could try doing that, you're going to create an equation that would fail the vertical line test. All right. Last part here, and then we're all done. Then you guys can get head start on homework. And homework is just going to be homework number 1 in your packets. Draw the inverse. Okay. Ooh, this is good. I like this. All right. I'll answer part B and C in a moment. Here's what I suggest you guys do, guys. Make a table. You guys, I need you to do this with me. So let's focus and swap X and Y. For table or inverse. Okay. So here's what I want you guys to do. Make a table for the original. So that should be pretty obvious just by looking at this. I know you guys can make the table pretty easily. Then what I want you to swap the columns and then plot it on the same coordinate plane. So let's make a table for the graph off to the left, the parabola. Give me some values that would make the table happy. 0, 0. Keep going, Nathan. 1. Negative 1, 1. Not 2, 2. 2, 4. 2, 4, right? Okay, guys, this is 1 right here. That's 1. Right?
Uh,
All right, so now what I want you to do is swap. Swap the columns. So you have 0, 0 still, 1, 1 still, but now you have 1, negative 1, 4, 2, and 4, negative 2. Yeah, Alexander, leave her alone. Thanks.
Watkins.
Thanks, appreciate it.
what?
Okay, so that's gonna be a sideways problem. And I'll explain some things that's happening in just a moment. You want to paint that. If I do likewise for the second graph, I should get this. I'll do the original over here. I think 3 points are good enough. 0, negative 1, half. We'll do 1, comma 1, and 2, comma 3. I think.
I didn't even notice once.
I'm just looking at the graph. Yeah. Negative 1, 0, 1, 1, 3, 2. All right. Now, this is the part that's not terribly obvious. I'll explain in a moment. All right, guys, we're almost done. Okay. All right, so let me direct you guys. Okay. All right. So what I did was all right, ready? Okay, thanks. Appreciate it. I made a table for the original graph, right? Plot counts points, wrote down, right? Swap the columns, do the new graph in green. And the dashed line is y equals x. So Jasmine, answer your question. The dashed line is y equals x. Pink line. Notice that y equals x cuts this quarter plane in half. If I were to cut out a square piece of paper right now and fold along the dashed line, the red curve and the green would map onto each other. So whenever you have inverses, are always significant y equals x.
You just eyeball that, or do you have to have like fun slope and stuff?
No, I didn't know. Well, I mean, what do you mean by eyeball?
In general.
The pink line.
Eyeball? Yeah.
Well, I just kind of did it freehand.
That's y equals x.
So it's y equals x, which is slope of 1 is what minus
Well,
0.
If,
Show.
if it splits the coordinate plane in half, but you're not sure if it's like exactly half.
It's gonna split two graphs. It doesn't split two graphs in half, but what it does, it creates a mirror image. Let me rephrase that. It creates a mirror image.
Mhm.
So these are mirror images of each other. Likewise with the red line and the green line, the second graph, they're mirror images of each other along the pink line. So that's another thing that we need to observe about inverse functions, which we'll talk more about on Thursday. Okay, I think that's enough for today. That's a lot for you guys to sit through and through the classes, and may have like sports or other stuff today. Homework is already in the extra packet, so you have a second packet of homework. I suggest either you do that or do homework for another class. If there's another class you want to work on, that's totally fine. But let's make sure we're not wasting time. So, sorry. So you can here. I'll take a screenshot too. All right, guys. So anyone wants to go over their file, you can just come up and talk, or if you just don't want to, that's fine too. So, all right. And guys, let's get homework done. It's the extra packet I gave you. This is homework number 1. Do you have it? You guys have the answer key as well.